Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. We live in a world governed by fundamental forces, yet our conscious experience of that world often seems disconnected from the rigor of physics. Take color, for instance. We see red, we see blue, but do we feel them? When asked to assign a haptic quality, a weight, to different colors, people around the globe consistently agree. Dark, long wavelength colors like red feel heavier, while bright, short wavelength colors like blue feel lighter. But what if this isn't just psychology? What if this common synesthetic correspondence has a basis in the underlying physics of light itself? Welcome to the incredible concept of the synesthetic weight of light. To understand this, we must first address a common misconception: that light is massless and weightless. While photons have zero rest mass, they are not without influence. Light carries momentum. When light hits an object, it exerts a tiny but measurable force called asterisk radiation pressure. This pressure is the physical weight of light, and it is a key element of the electromagnetic field theory, proven by experiments like the Crookes radiometer. This is where the colors come in. Color is determined by wavelength. Red light has a longer wavelength and lower frequency, meaning its photons carry less energy. Blue light, conversely, has a shorter wavelength and higher frequency, meaning its individual photons carry slightly more momentum and energy, as described by Planck's equation, E equals h nu. If blue photons carry more individual energy than red photons, shouldn't blue light exert a stronger physical pressure, and therefore feel heavier? Logically, yes. However, the difference in pressure is astronomically small, far too minute to be registered by the tactile senses. So, the physical reality must interact with cognitive processes in a subtle, counterintuitive way. Cognitive scientists point to the phenomenon of asterisk cross-modal correspondences. Our brains are masters of mapping abstract sensory inputs onto concrete physical concepts. Think of the famous Kiki and Booba effect. We instantly know that the spiky, angular shape is Kiki, and the round, blobby shape is Booba. We map visual texture to auditory sound. We do the same with color. Researchers hypothesize that the perceived weight of color is driven not purely by the imperceptible physical pressure, but by the complex interaction of three main factors: value, saturation, and the physical reality of the color's energy. First, there is asterisk value, brightness. Darker colors absorb more light and are generally associated with density and depth, leading to the perception of greater weight. Secondly, saturation, intensity, increases perceived weight. But the third factor, the energy relationship between red and blue, offers the deepest physical connection. While blue light carries higher energy per photon, it is often associated with the sky, water, and vastness, elements that are spatially expansive and often perceived as airy or light. Red, being a danger signal, associated with earth, fire, and density, holds strong connotations of groundedness and weight. Studies testing this correspondence consistently show that dark colors, regardless of whether they are physically high energy, like dark blue, or low energy, like dark red, are universally judged as heavier than light colors. However, when tested under conditions where the visual value is carefully controlled, for example, comparing a medium value red against a medium value blue, the underlying cognitive bias towards blue being airier prevails, overriding the minimal difference in radiation pressure. In essence, the physics of light gives us a starting point. Blue light truly is more energetic and, photon for photon, carries slightly more push. But our brain interprets this reality through the lens of psychology and lived experience. The concept of the weight of light, though initially rooted in quantum mechanics, is ultimately translated by the brain into a profound and universal synesthetic experience. The synesthetic weight of light shows us that our senses are not isolated channels. They are constantly cross-referencing, linking the objective properties of the universe, like the momentum of a photon, to our subjective, internal reality. It's a beautiful demonstration that even the most abstract concepts of physics might secretly be shaping how we interact with the world around us, one subtle color association at a time. For more incredible facts like this, don't forget to subscribe and turn on notifications.